This is Naming Alkanes with Functional Groups, Part 2. In this video, we're going to go over some functional groups whose presence changes the parent carbon suffix. They all follow the same general naming protocols. First, if the presence of a functional group, in this case a hydroxyl group, which makes this molecule an alcohol, changes the parent carbon suffix, then you try to give the functional group that changes the suffix the lowest possible number when numbering the parent hydrocarbon. Again, we count the carbons. We see here there are 8 carbons. The hydroxyl group, which makes this an alcohol, is at carbon 2, and the methyl group is at carbon 5. When an alkane is an alcohol, we remove the E from the end of the alkane's parent carbon name, and we add an OL instead. Therefore, this is 5-methyl-2-octanol. Our next alkane contains an amine. An amine is a functional group where one or more of the hydrogens in ammonia, NH4, are replaced by an alkyl group. Here we see there is an amine that has an additional carbon chain coming off of it. So this would be a secondary amine, meaning there are 2 alkyl groups. When naming an amine, we replace the E at the end of the parent hydrocarbon name with amine. Any group that is attached directly to a nitrogen instead of the carbon chain gets an N preceding it to indicate that it's bound to nitrogen and not to carbon. Since there are 7 carbons, this would be heptanamine. Since the amino comes off at the number 3 carbon, it would be 3-heptanamine. And since ethyl is attached to the nitrogen, which is the substituent, it would be N-ethyl-3-heptanamine. Finally, we're going to look at a carboxylic acid. A carboxylic acid has a C double bound to an O, which is called a carbonyl group, and the same C attached to a hydroxyl group, which is, as you recall, the identifying molecule in an alcohol. With a carboxylic acid, you always number the carbonyl carbon as number 1. Therefore, we'll count this way. We see that there's 1, 2, 3, 4, 5, 6, 7 carbons. Since we always label the carbonyl carbon as number 1, there's no need to identify its position. And in a carboxylic acid, we change the E ending the parent hydrocarbon name to oic acid. So this would be heptanoic acid.